In our last video, we learned that we can graph vertex form by following a set of transformations that's happening to the parent graph to create our new graph. For example, this number one will be moving the points, and then I'm going to erase everything on number one and show you how we can also make those same moves mathematically with a table. So this is the most kind of non-mathematical way to do this in terms of we're going to be moving things, we're going to be following steps, but we're not going to be adding, subtracting, multiplying, dividing, any kind of operations, anything like that. So the first thing we're going to look at is what are the transformations that are taking place here. So we are in vertex form, which means when we look inside here, x is being affected, and we use the opposite. So the first transformation is right 2. So even though that's a negative 2, our first transformation is actually move right 2. Then we look in the front, and there's not a flip, right, an x-axis reflection. There's no flip, but there is a stretch of 2. So our y value is stretching by 2. And then the whole thing is shifting up 1. So which really affects our y value, again, up 1. So anything that affects our x value that's moving left or right is taking place inside the parentheses. It could also stretch or shrink, but that would have to be inside these parentheses. Everything outside of the parentheses are only affecting our y value, and that's important for the new technique that we're going to learn, so just keep that in mind. So the most important part from using a parent graph and then creating a transformation is remembering that the parent graph for a quadratic would be if we just had y equals x squared. That's our most basic quadratic, nothing really affecting it, changing it in any way. And then all of these steps are going to affect and kind of change or morph our parent graph. So I'm going to start by graphing our parent graph in blue here. And actually I'll do a table first. And we could put any values in the table here. But for a parent graph, we usually like to use -2, -1, 0, 1, and 2. Those are kind of our 5 favorite numbers. And essentially what we're saying is for our parent function, if x was -2, what would we get for y? Well, -2 squared is +4. -2 times -2. -1 squared is +1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So this table, I'm going to be using this table again with our other way of graphing. This is a very important table, our parent function table. So if I were to graph this, I'd find -2 and go up 4 and put a point. I would go -1, up 1, put a point. 0, 0. 1, 1, and 2, 4. And these are all the points for our parent function. So in the last session, we talked about how these transformations are affecting these points. The first way that these points are being affected is they're moving right 2. So every point moves right 2. Right 2 means all 4 of my blue points moved right 2. In fact, I'm going to do something that might make it easier to see. We'll see here. I'm going to grab all of these points and I'm going to slide them over right 1, 2. Pretty close. There we go. Right 2. Now, our stretch of 2, this is a vertical stretch. So whatever our y value is for each point, we're going to multiply that by 2, and that's going to give us our new y value. So for this point, our y value, I'm going to do that in orange. So right 2 I did in blue, I guess. I didn't really do anything. I just grabbed them all and moved them. Stretch them by 2, I'm going to do in orange. So I'm only worried about my y value here. The y value for this point is 4. So if I did 4 and then multiplied that by 2, 4 times 2 is 8. So I now have a new y value of 8. And I do that for each point. The y value on this is 1, so 1 times 2 is 2. The y value for this point is 0. 1 times 0 is, or I'm sorry, 2 times 0 is 0. And then our y values, 1 times 2 and 4 times 2 is 8. So now my new set of points is in orange, or they are in orange. And then my last step is to move up 1, and I'm going to show you that in green. So here's up 1. So my final, kind of after all of my transformations, this is my new graph. This is a graph of this function right here. And we just did all the transformations. So let's get rid of that. There we go. So this is really our answer here. I'm doing it on my iPad. It makes it really easy to kind of erase things. Had you have not erased anything, you would have all kinds of points there, and it gets really kind of confusing. So there's no real math. We're just moving each point, but it gets confusing. So I'm going to show you. I'm going to leave these green points. I'm also going to leave my parent graph. I'm going to grab it and move it over here so that we can compare it with what we're doing. Okay. So earlier I talked about, so this is a different way to graph these, and we're going to end up getting these same green points here. When we look inside, right 2, when we look inside here, this is the only thing that's affecting our x value, and it's moving right 2. So I'm going to create a table down below, and my table is going to be x plus 2. I got that from the opposite of whatever is inside with x right now. So x plus 2. My y value is being stretched by 2, which means we're multiplying y by 2, so 2 times y. And then we're moving up 1, so plus 1. Take a moment to compare our original to our function down here, and really our parentheses squared, this whole thing, we kind of just replaced it with a y. I got rid of this in green, and essentially look at the difference. I just replaced it with a y. So instead of 2 times the quantity x minus 2 squared plus 1, it's just 2y plus 1. So that's kind of a shortcut trick to remember. You can use that to check. Okay, so using my the vertex form that I was given, I wrote down the transformations in terms of how they're happening to the points on a table right here. And we are going to take all of my x values here. So I have, and I'm going to replace x over here with those values. So -2, -1, 0, 1, and 2. And all of those x values are having 2 added to them. I got that from right here. Let's see. I'm going to use, let's see, we use green up there. So I'm going to graph this in purple. So these are each going to give me an x coordinate. There is a corresponding y coordinate. So all of my y values, I had 4, 1, 0, 1, and 4. And hopefully you've kind of seen that these line up with one another. Let me try and organize this. If we were in class, I'd probably try and come up with some clever way for you to have an organization tool so that we could keep track of this. So in red, all of my y values I took from right here. They're being multiplied with 2. So 2 times all those things. And then they're having a 1 added on at the end. And those are going to give us some values. Okay, this is kind of the hardest part, is building this out. And it looks like a lot of work, but it's a lot of kind of simple math. -2 plus 2, signs are different. I'm looking right here. Signs are different. Subtract, keep the sign a larger number. Should get 0. -1 plus 2, 0 plus 2, 1 plus 2, 2 plus 2. Those are my x coordinates there. For my y's, I do have to follow order of operations, so I'm going to multiply first and then add this 1. So 2 times 4 is 8, plus 1 is 9. 2 times 1 is 2, plus 1 is 3. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. And 2 times 4 is 8, plus 1 is 9. And if you notice, just like we did earlier when we graphed with tables, because these are quadratics, they're parabolas, this part is going to match this part here. So I'm going to highlight these in purple now. 1 and 9, I'm sorry, 0 and 9, 1 and 3, 2 and 1, 3 and 3, 4 and 9. My x coordinate, comma, my y coordinate. So if I were to plot these on my graph, 0, 9 is right here. Oh, that's right on top of that. 1, 3 is right here. Oh, look at what's happening. 2, 1 right here. 3, 3, and 4, 9. So we got the same exact points, but instead of moving all of the points on the graph from the parent graph and moving them, we used the parent table and we transform them, we move them on a different table. And I personally think that's a little bit easier than trying to keep track of all of these points. There's my parabola. Not very nice, but there you have it. Let's do the same thing over here. So instead of using a parent graph, we're going to use the parent table. And our parent table is always going to be the same for these quadratics. We're going to have 0 or -2, -1, 0, 1, and 2. And we're going to get 4, 1, 0, 1, and 4. And then we're going to use the transformations that's happening here, and we're going to apply them to a transformation table over here. So to figure out what's happening with x, we look inside the parentheses and we use the opposite. So we're going to say x plus 2. So whatever our number is for x, plus 2. And then on this side, we're going to take pretty much everything on the outside. I'll use orange here. So -2 times y plus 4. So -2 times y plus 4. And now that I have built this out, and maybe it's a little bit easier to see if I organize these. Okay, so my x values come from here. So I'm going to write those in red. -2, -1, 0, 1, 2. And those are being added by 2. My y values, it's going to be a little bit more work, but it's not too bad. My y values are 4, 1, 0, 1, and 4. And I'm building out the rest of this. It's being multiplied by -2, and then we're adding 4. It's a lot of writing. It's a little more mathy, but the math itself isn't quite difficult. It's just kind of a lot going on. So let's think about this. Okay. I'm going to do all my answers in purple again. -2 plus 2, 0. -1 plus 2, 1. 0 plus 2, 2. 1 plus 2, 3. 2 plus 2, 4. It doesn't always happen with the same numbers, but if you notice, we had the same sets here, so it does end up giving us the same function down below. And then in purple, -2 times 4 is 8. -8. Plus 4 is going to give me -4. -2 times 1 is -2. Plus 4 is a +2. -2 times 0 is 0. Plus 4 is 4. -2 times 1 is -2. Plus 4 is 2. And -2 times 4 is -8. Plus 4 is -4. Oops. I have enough room there. There we go. Okay. So I can plot each of those points. 0, -4, be down here. 1, 2 is going to be up here. 2, 4 is going to be up here. I'm pulling these from my table, my purple numbers. 3, 2 is right here. And 4, -4 is down here. And there is a really bad parabola. So instead of writing all the points down and moving all the points, we did it with math down here. All right, I'm going to do these last two examples and then send you on your way. So instead of using a parent graph, we're going to use our parent table. That's our 5 favorite numbers. -2, -1, 0, 1, and 2. And those each have an output of 4, 1, 0, 1, 4. Same numbers every time. Then I'm going to build a parent table over here. This one's also x plus 2, because I did the opposite of what was in here, x plus 2. And then we have a stretch of 2, so 2 is multiplying with y, and then plus 3. So I'm saying 2y plus 3. Essentially, I'm getting rid of I'm replacing my parentheses squared with a y. Okay, and now I'm using my x values. And my y values. And then I'm using the rest of the information given to me. So this is plus 2. And this is times 2 plus 3 times 2 plus 3. Okay, and then all we're doing from here is calculating these out. So 0, 1, 2, 3, 4. Over here, 2 times 4 is 8, plus 3, 11. 2 times 1 is 2, plus 3, 5. 2 times 0 is 0, plus 3, 3. We're going to get 5 here. Sorry, my other 3 kind of looks like a 5. Let me fix that. and then 11. 2 times 4 is. Okay. So here are my points. And if I wanted to list them out, I could. I have 0, 11. I have 1, 5. I have 2, 3. I have 3, 5. And I have 4, 11. Those are all points on my quadratic. So 0, 11 is all the way up here. 1, 5. 2, 3. 3, 5. 4, 11. It's really poorly drawn. But my points are correct. All right, and the last one. This is the most simple. There's only two changes taking place here. We're having our parent table with our 5 favorite numbers, -2, -1, 0, 1, and 2. It's 4, 1, 0, 1, and 4. And then we have a transformation with x. It's actually going to be x minus 2 now, because we do the opposite of what's inside the parentheses. And then we're saying, well, there's nothing multiplying with y out front here, so it's just a regular old y, and then we are going down 1, so it's -1. Because our x's influence are left and right, our y's influence are up and down. So if we're being stretched, it's stretching the y, not the x. Okay, so I'm going to replace my x with -2, -1, 0, 1, and 2. Those are my x values from over here. I'll replace my y's with my y values of 4, 1, 0, 1, and 4. And then I'm following whatever I've written up here. So that's -2 to everything. This one's -1 to everything. Not that bad. So this should give us -4, -3, -2, -1, 0. So those are my x values there. 4 minus 1 is 3. 1 minus 1 is 0. -1, 0, 3. So if I were to write these as ordered pairs, I'd get -4, 3, -3, 0, -2, -1, -1, 0, and 0, 3. All of these gave me my x values, all of these gave me my y values, and they match up with each other there. Okay, so I'm just going to plot this, graph it, call it good. So -4, 3, -3, 0, -2, -1, 0, -1, and 0, +3. And there we have a nice parabola. Okay, hope that makes sense. We'll practice with it some more. But there were two ways. We could either we could put the parent points on the graph and then move those parent points, or we can make a parent table and then change the numbers in the table using our transformation.